Hello and welcome back to Amulya's Academy YouTube channel. We were discussing BFS graph traversal algorithm. Today let's write a Python program to traverse the graph using BFS algorithm. So here we have our program: add node function, add edge function, DFS function, as well as here we have graph, that is a dictionary, add node function and add edge function. Today we want to write a function for BFS algorithm. So let's write here def keyword to define a function, then followed by function name. Here I'll give function name as BFS because we want to write a function for BFS algorithm. Next let's write the parameter. Here, to traverse the graph using BFS algorithm, first we need a starting node. We can choose any node of the graph as the starting node, but we need a starting node. So let's take a parameter called node. Next, we want to traverse a graph. To traverse a graph, we need a graph, right? So here we need to pass graph also. Next is, while traversing a graph, after visiting a node, we need to mark that node as visited because we don't want to visit that node multiple times, right? We want to visit a node only once. So for that, to maintain that visited nodes, we'll use a set. So I'll take that set name as visited1, and here in the beginning of the graph, let's take a set. Let's create a set. So we need three parameters. First one is starting node and graph and also visited set. Next, inside the function, the first step we need to do is we need to check whether given starting node is present in the graph. If that given starting node is not present in the graph, then how to visit that, right? So the first condition we need to check is whether the given starting node or mentioned starting node is present in the graph. So for that you can check if node not in graph, right? I'll use not in operator. If node not in graph, then I'll just print a message, right? And here I'll use return. So if node is not present, then print this message, then exit the function. If not, then only we'll start the traversal operation. Okay, how to traverse a graph using BFS algorithm? As we learned in the previous tutorial, BFS uses queue data structure, right? First, we need to choose the starting node and we need to insert that starting node to an empty queue. First step. Next, we need to visit that starting node. Then we need to remove that starting node from the queue. And we need to add all the unvisited adjacent node of that starting node to queue and mark them as visited. Then I need to remove a node from the queue and I need to repeat the same pattern, right? Same process. Remove the node, add all the unvisited adjacent node of that removed node to queue, mark them as visited and remove the node. We need to follow these steps. So for that, first thing we need to do is we need to create a queue. Here for queue, you can use list as queue or you can use dequeue class from the collection module. So if you use list as queue, then we need to create a list. Then to insert, you'll use append, queue.append, and to remove, you need to use queue.pop0. Or you can use dequeue class. You need to use from collections import dequeue, and you need to create a queue. To insert the node, you need to use queue.append. To remove, you need to use queue.popleft. First, let's use a list. Queue is a list. Next step is you need to add the starting node to empty queue. Here we have starting node. So add that to empty queue. Queue.append node. Next, we need to mark that starting node as visited, right? Visited one dot add. Next step is we need to remove that node from the queue. So for that, I'll use pop method, queue.pop0, and this pop method return a value. It will return a value. So to store that, I'll use a variable, for example, current. So the removed node from the queue is stored in this current variable now. Next, what I need to do, I need to find all the adjacent node of this current removed node, and I need to add that unvisited adjacent node to the queue. To find all the unvisited adjacent node, it can contain one adjacent node or more than one adjacent node, right? For that, we'll use for loop. For I in graph current, to get the adjacent node of current, you need to use graph of current. You need to use this as key, so we'll get its value. Its value is nothing but adjacent nodes, right? And here we need to add all the unvisited adjacent node to the queue. So first we need to check whether that node is visited or not. For that, you need to use if I not in visited 1. If I, that is the adjacent node, is not already visited, then only add that to queue. So here queue dot append I, and next mark those nodes as visited. For that, visited 1 dot add I. Next, we need to remove the first element, that is we need to use pop method to remove the first element from the queue, and we need to find all its unvisited adjacent node. We need to add that to queue and we need to mark them as visited. We need to repeat this process until queue becomes empty. So we need to include this part of code inside a loop. Okay, I'll use while loop, while queue, that is until queue becomes empty, I need to repeat this process. When queue becomes empty, stop the execution. First, we need to check whether given starting node is present in the graph. If it is not present, then just print this message and stop the execution of the function. If it is present, then we'll create a queue and we'll add that starting node to queue and we'll mark that node as visited. Next, we need to remove that node from the queue and we need to add all the unvisited adjacent node of that removed node to queue and mark them as visited. We need to repeat that process until queue becomes empty. Okay, so we are done here. Let's call this function here print BFS Let's take starting node as A and graph and visited 1. So let's save this and execute this, and here we won't get anything because if we print here current, that is removed nodes, okay, then we'll get nodes. So save and execute now, and here you can see nodes, or you can print visited 1 and visited set also. Okay, so this is about BFS algorithm. Next, as I said, you can create the queue using dequeue class also. For that, you need to use from collections import dequeue, and here in the BFS, here instead of queue you need to use dequeue. Here queue dot append, but for pop you need to use pop left, you need to use 0. Okay, now if I save this and execute this from collections, okay, and here you can see nodes. Okay, next let's take few more examples, few more graphs. So here we have another graph. Starting node will be same. Let's execute this, and here you can see and let me take different starting node, and here you can see the output. We can take another graph. Let's take another graph. Okay, so save, and here you can see the output. Okay, so this is about BFS function, how to traverse a graph using BFS algorithm. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.